suspended in silence over 1 million miles from Earth at the second Lagrange point. The James Webb Space Telescope drifts far beyond our world, steadily observing the cosmos. Its precisely calibrated golden mirrors, protected from the blinding light of the sun, have unlocked a view into the earliest epochs of the universe farther and deeper than any telescope before it. For months, it swept across distant galactic horizons, gathering the faint light of stars that began their journey billions of years ago. During one of its routine deep-field observations, an effort to study one of the earliest known galaxies, Webb encountered something wholly unexpected. This discovery was so improbable, so counter to current astrophysical understanding, that it shook the foundation of cosmic science. As Webb's sensors focused on a seemingly unremarkable sliver of the sky beyond the reach of all previous instruments, it revealed a structure that appended existing cosmological models amid the dim glow of ancient galaxies. The telescope captured an object that stood out starkly compact, luminous, and broadcasting a spectral signature that defied classification. It wasn't simply an undiscovered galaxy or a particularly bright quasar. The chemical and energetic data emanating from it were by every measure. It's possible for something existing at such an immense distance and early time in the universe's timeline, estimated to be about 13.5 billion light-years away. The object appeared to exist just a few 100 million years after the Big Bang. During that era, the universe should still have been in its dark ages, a period before stars and galaxies had fully emerged. Yet this object radiated with an intensity and complexity that suggested a level of organization far beyond what science believed possible for that epoch. Its structure was not chaotic or diffuse like other early formations, but instead appeared symmetrical and geometric. Webb's instruments revealed repeated alignments, concentric formations, and lattice-like arrangements, features too ordered to be accidental. It wasn't a Dyson sphere, a theoretical megastructure encasing a star, nor a ring world or any other construct previously imagined in speculative physics. This was something entirely unfamiliar in concept and in form. Its very presence in the early universe was a contradiction. Spectrographic analysis only deepened the mystery. Emission lines revealed highly ionized elements, including heavy metals, that shouldn't have existed in any abundance during that time. These elements typically require multiple generations of stars and explosive supernova to-form processes that unfold over billions of years. Yet here they were, concentrated in a structure older than most stars in our own galaxy. Even more startling was the nature of the radiation itself. It didn't just mirror stellar activity, it suggested deliberate control, a regulated release of energy that couldn't be explained by gravitational collapse or fusion alone. The object's very existence appeared to defy the conventional sequence of cosmic evolution. According to accepted models, the early universe was a place of gradual, simple formation, where matter slowly coalesced into stars and galaxies. Level of sophistication implied by this structure should not have appeared for billions of years, if ever, adding another layer to the enigma. Scientists detected movement in the object. By analyzing time-separated observations, subtle changes were noticed that couldn't be explained by cosmological redshift alone. The structure appeared to have intrinsic motion, possibly spinning or vibrating, discernible even from Webb's distant vantage point. More intriguingly, this motion followed a rhythm. Infrared emissions pulsed at regular intervals, like signals. These weren't random bursts of energy. They were narrow, precise, and repetitive, resembling how a beacon might behave. This raised unprecedented questions. If the object were artificial, it would imply that intelligent life had arisen astonishingly early in the universe's history, almost as soon as matter itself had stabilized. That would place the emergence of technology billions of years earlier than even the most optimistic projections. On the other hand, if it were a natural phenomenon, then it represented an entirely new category of cosmic entity, capable of organizing energy and matter in ways we have never seen before. The implications didn't stop at cosmology. Its anomaly forced scientists to reevaluate the laws of thermodynamics, the arrow of time, and even the foundations of information theory. If such complexity could arise so early, it suggested that the universe's unfolding might not be the slow, heat-driven process once assumed. Instead, there may have been unique pockets where order and complexity flourished under unknown principles. Some began to speculate whether this object pointed to a parallel track of cosmic evolution, one not dependent on biology or Earth-like conditions, but governed by different forces altogether. The possibility emerged that intelligence might be embedded in the very physics of the universe itself. Continued observation only deepened the puzzle. Polarization data revealed the structure had magnetic fields of remarkable complexity. These fields weren't simply remnants of stellar processes, they displayed patterns, suggesting continuous modulation. Whether this was the result of advanced engineering or an entirely unknown type of magnetism, the implications were staggering. Normal magnetic fields fade or decay, but these appeared regulated, patterned, and active. There were further anomalies. Light from distant galaxies passing behind the structure was bent in ways inconsistent with standard gravitational lensing. Instead of smooth curves, the distortions appeared teardropped, as though gravity itself were being manipulated in discrete steps. This kind of gravitational control had only been hypothesized before, and it would require either a massive source of exotic matter or the existence of negative energy densities. Additionally, the structure didn't just emit energy, it echoed it. Infrared reflections displayed decay curves that hinted at a hollow interior, capable of reflecting and managing energy flow. This was more like a mechanism than a naturally occurring object. These echoes pointed toward internal architecture. Cavities designed to regulate radiation, just as machines regulate heat and signal pathways. More evidence pointed to the object being active. Thermal scans detected slight fluctuations across its surface, temperature changes that pulsed in rhythmic patterns. These were not the result of random heating from the surrounding interstellar medium, but resembled the regulated cooling systems of machinery. It was as if the structure were breathing, not biologically, but thermodynamically, maintaining its internal state across eons. This led some to a staggering realization. The structure might not be inert. It could be self-regulating, perhaps even self-aware in a way not comprehensible through biological analogies. If it was technological, it wasn't just advanced, it was impossibly old. Likely predating the formation of the Milky Way itself. Was it a remnant of a civilization long since vanished? A probe? Seed? Or something even more fundamental, an expression of intelligence embedded in the universe's very framework? As researchers scoured Webb's data for similar anomalies, the question changed from what is it to how many more like it exist. If this object was alone, perhaps it was an isolated fluke. But if others were found, a new paradigm would emerge. The early universe may have had a structured, deliberate architecture, like an invisible scaffolding only now becoming visible. Data. Scientists, theorists, and experimental physicists were drawn into the effort. Entire simulation models were revised to test whether any known process could recreate what had been seen. Nothing fit. Not a single model could replicate the energy patterns, structure, or magnetic behavior observed. Even cutting-edge AI trained on vast amounts of cosmic data failed to generate analogs. It was like trying to reproduce a symphony. Using random notes, the structure, intention, and meaning were missing. In the end, what Webb had encountered may not have been just an object. It was a message expressed not in language, but in form, energy, and time. It communicated through the resonance of radiation, through the warping of space, and the rhythm of pulses across a void. It asked questions no one knew how to answer, and challenged everything thought to be true about the cosmos. And so, in the vast silence of space, among fading starlight and drifting galaxy, something stood, impossible, ancient, watching in the days and weeks that followed. The investigation only expanded. Data from additional observations revealed even more details, each more confounding than the last. Researchers adjusted their approach, narrowing the range of infrared spectroscopy in hopes of isolating discrete signals. They discovered frequency, patterns that were not random but harmonically structured patterns that resembled mathematical functions embedded in the radiation itself. The emissions didn't form a smooth continuum. Instead, they contained peaks and valleys, spaced with uncanny precision. These intervals echoed irrational mathematical constants like pi or the golden ratio patterns too perfect to be natural. This wasn't starlight. It was something closer to a code. The light itself appeared to be manipulated as a medium for conveying information. Scientists began to wonder, was the object broadcasting? If so, then this signal had survived across nearly the entire lifetime of the universe, and that possibility redefined the telescope's role not as a passive observer, but as a potential decoder, translating messages hidden in ancient light.